So this video is about a one-way analysis of variance, or an ANOVA for sure. What we're doing is we're comparing multiple group means. So we've got a dependent variable which is continuous, and so we can calculate a mean for it, and an independent variable which is made up of various categories. So we're comparing the mean on the dependent variable for each category to see if there are statistically significant differences between these different groups. The example we'll look at here is whether there are differences in age 14 exam scores between different ethnic groups. The null hypothesis being that all of the ethnic groups score exactly the same at age 14 in their exams, but our actual alternative hypothesis being that there'll be differences between the different ethnic groups. So let's quickly run through how you do this. We go to Analyze, to compare means, and it's the bottom one here, one-way ANOVA. And we get our window here. So the dependent list is your dependent variable, which in this case is KS3 stands, so that's the standardized age 14 exam score. And our factor will be ethnicity, so ethnic. Before moving on, we should have a play with some of the settings here. So the most important one, and the one which is the most confusing and overwhelming, is the post hoc tests. Now basically what the ANOVA is doing is, the ANOVA analysis of variance itself is just telling you if there is any differences between your groups. So we'll have to carry out what are called post hoc tests to find out where the differences actually lie, i.e. whether there's a difference between white British and black Caribbean, or white British and Indian, for example. So if we find that there's an overall difference, we'll have to find out where those differences actually lie by looking at the categories in a pairwise fashion. We're going to go for the two-key post hoc test. Now I won't go into sort of a great depth at describing these. You can see that there are different types of tests for whether you've got equal variances assumed or not, and each test basically is different in the sense of how conservative it is, or what it's best at looking at. But we'll leave you to sort of read some of the other sources on this, because it's quite complicated. What you'll actually find is a lot of the time, if there are substantial differences between groups, then all of these tests will detect them. But we like the two key, so we'll go for that. If we click continue and look at options, it's also always good to get the descriptive statistics, because that'll give you an idea of what the means for each group are, and sort of an idea of how big the gaps between groups are. Again, just click continue when we're happy to close that window, and click OK to run the actual analysis. Okay, so we can see here that we've got the descriptive statistics for each of our groups. So this here is the mean score at age 14 for each of our different ethnic groups, and you can already start to tell that there's likely to be statistically significant differences, remembering that the sort of the age 14 score is standardized, so 0 is the mean. We can see that white British tend to score above the mean, and these minus figures here, the Pakistani, Bangladeshi, black Caribbean and black African groups all score below the mean, Indian scoring above the mean, and mixed heritage scoring quite close to the mean. So we've got the basic descriptive statistics for each of these groups, their mean score, how many were in that group, and you can see that the most frequent group is white British. Standard deviation, standard error, maximum and minimum scores. So we can see straight away where the differences between our groups could lie from this descriptives table. And we now need to go and find out if these differences are actually statistically significant. So the ANOVA table tells us whether there are any statistically significant differences between the groups. So it's what's known as an omnibus test. It tells you whether there's an overall effect, but it doesn't tell you what the effect is or where it lies. And you can see that the F value here, which we're looking at, this F ratio, is statistically significant, much less than 0.05. Again, 0.005 actually, it's less than 0.005. So we can be very confident that there are statistically significant differences between our groups. What we don't know yet is where these differences lie. I mean, by looking at this table we can have a good guess, but we can't tell which of them are statistically significant, so we need to use our post hoc test to find out where the differences are. Now I won't go through the whole table, because as you can see, what it does is it compares each individual ethnic group with each of the others to tell you whether there's a statistically significant difference. So we'll just look at the top one here, white British, to sort of give you an example of this. So it will compare white British with mixed heritage, tell you the difference between the means and whether or not that difference is statistically significant, taking into account also, of course, the standard deviations of the two groups, so the variances of the two groups. Looking through it, we can see almost, which is reflected with our means up here, we can see that the mean differences are such that the ones for Pakistani, Bangladeshi, Black Caribbean and Black African are all statistically significant, less than 0.05, but the differences between white British and Indian, mixed heritage and any other group are not statistically significant. Now if we were interested in any of the other, you could look at all of the comparisons between all the different ethnic groups. You could then look at mixed heritage versus Indian and see, again, no statistically significant difference. Mixed heritage and Pakistani, and again a statistically significant difference with this sort of 4-point difference in the mean. So you could analyse this table in quite a lot of depth to look at these sort of what are known as pairwise comparisons, this sort of post hoc analysis after the ANOVA. So overall, again, the ANOVA tells you whether there are statistically significant differences within the overall effect of ethnicity, and then you use the post hoc tests to look at these pairwise comparisons to try and work out where these differences might actually lie. Before I move on, I'll try and show you this graphically, which is quite a good exercise. So if you go to Graphs, Legacy Dialogues, and Error Bar, and just go for Simple, and the variable we're interested in is, again, it's KS3 stand, and ethnicity as the category axis even. Click OK, and you can actually see sort of visually. So these are your error bars. So we're 95% confident that the true mean for each of these groups lies between these bars. And you'll notice that the one for the white British is a lot smaller, simply because it's such a larger sample. So there's sort of, we've got scroll back up to the descriptives. We've got 9,400 plus white British students, but sort of between 500 and 1,000 for the other groups. So we can be that much more confident in our range, that we're happy that the mean actually lies in with that group, because we've sampled such a bigger group of that population. But as we saw statistically through the analysis of variance and the post hoc tests themselves, the Pakistani, Bangladeshi, Black Caribbean and Black African groups do seem to score lower on average at age 14 than the other groups. And you can see that there might not be a statistically significant difference between mixed heritage and white British, which we found because there's such a lot of overlap between these confidence intervals. Now we'll explore this in a lot more depth when we come on to do regression analysis, so the story of this particular bit of research doesn't end here, but I think it's good to see it graphically in that way. Okay, thanks very much.